All right, so in this statement, we're going to be changing things just a little bit. So in this case, we're going to be looking at the statement that says Jeff owns a toy store if and only if he likes board games. So you can still see we're still talking about my friend Jeff and his owning a toy store and whether or not he likes board games. But now the separating connection is going to be this somewhat fancy statement that reads if and only if. You can still see kind of there is going to have these two different bookends. I'm going to have my initial statement A, which is going to say Jeff owns a toy store. And I'm going to have my secondary statement, my statement B, the other bookend, which is going to say that Jeff likes board games. The connection or the operator between these two things is going to be this statement if and only if. What this is read as is a biconditional statement. And what it's going to be viewed as is going to be two separate little conditional statements. What it's going to say is in one direction, I'm going to have the fact that Jeff owns a toy store, then is going to imply that Jeff likes board games. But it's also going to do the other direction. It's going to come backwards. It's going to be the fact that if Jeff likes board games, then Jeff owns a toy store. So you can see that it's going to now be a two-way street. It's going to go the forward direction as well as the backwards direction. We'll see a little bit later, kind of once we start talking about this notion of equivalencies, what this is going to say is it's going to have the statement A, if and only if B, which is going to be this two-headed arrow. So somewhat suggestive notation. It's going to be an arrow that points from A towards B, as well as an arrow that comes from B and goes back to A. What this is going to be is it's going to be equivalent to the statement that says A goes to B, as well as B goes to A, and these things are going to be connected by an and, which is exactly what you could say this statement as. If you didn't want to write this as an if and only if statement, you could say this kind of super longhand as if Jeff owns a toy store, then he likes board games, and if Jeff likes board games, then he owns a toy store. So it's kind of gigantic way to say two separate conditional statements, but I can combine these things into one really pretty slick biconditional. And some people don't like using biconditionals because it becomes somewhat cumbersome to work with, but it does become a huge time saver. As long as you're okay with working with these things and kind of seeing what's going on, it becomes somewhat pleasant to work with. Really what's going to happen is that when you start to think about the truthfulness of one of these types of biconditional statements, we're actually going to look at these two things over here, compare them with this and then come back to actually say what's going on with this biconditional. So to do this, I'm going to create another one of these truth tables. I'm going to have the options for A. I'm going to have the options for B. I'm going to look at what happens with A implies B. I'm going to look at what happens with B implies A. And then I'm going to do this A implies B and my B implies A. And at the very end, I'm going to talk about this biconditional. And you're going to see that these two things actually happen to be the exact same. A little bit of foreshadowing on we're going to see this notion that two things happen to have the same truth value is going to say that two statements happen to be logically equivalent. And that's exactly what this is. This biconditional A if and only if B is going to be logically equivalent to A implies B and B implies A. So it's one of those, if you're a minimalist when you try to come into the world of logic, you can see that you don't ever need this biconditional because you can get by with just using two conditional statements separated by an and. And that's kind of the way that I like to work about. I don't like developing additional symbols just because I like having extra symbols. I like to work with what is the fewest number of things I can work with. But the biconditional comes up over and over again when we start to actually talking about proofs again, that it's useful to have a little bit of the logic underneath it. So in this case, let's think about all the different versions that A and B can have T's and F's. So I got my T, and an F, and an F, and I'm going to have a T, and an F, and a T, and an F. So first off, I'm going to have the conditional statement A implies B. The only time that's going to kick out a false is that particular situation where A is true and B happens to be false. I satisfy my hypothesis, but I fail my conclusion. So that's the one and only F. All of the others are going to be true. On the other direction, I'm just going to be basically flipping the order of things. I'm going to be looking at when does B imply A. So in this case, I want to think about when is the only time that's going to kick out a fail, which is going to be when B is true, but A is not. So it's going to be this third one because things are mixed up a little bit over here. So in this first one right here, I'm going to have this T implies an F, which is going to kick out a false. All of the other ones are going to be true. You can see I'm going to have a true implies true, which is true. Here I'm going to have a false, and I really don't care what's following that because I know that I'm going to have a false in my hypothesis, so I'm never entering that if statement. Everything is totally fine. I'm going to have a true overall statement. And then last but not least, if I have a false, again, I don't care what follows that. It's going to be a true. Now I'm going to try to compare these things, and I'm going to connect these with the and, this conjunction operator. I'm going to try to see when do both things happen to be true. Those are going to be the times that this is going to kick out a true. So I'm going to get a true there, and I'm going to get a true there. In the other two cases, I'm going to have falses. So in this case, you can in fact see that I have this kind of truthfulness of this statement A implies B and B implies A. That's going to happen when I have a true here and a true down here, which is occurring when these two objects are both going to have the same sign. And that's exactly what this biconditional is defined as. So in this case, A, if and only if B, is going to occur when A and B have the exact same truth value. Be the same. So if I have true and true, I'm good. That's going to kick out a true. And if I'm false and false, I'm still good as well. The only time it's going to kick out false is if there's a mismatch. So in this case, I have one true and one false. That's going to create a mismatch in my biconditional, which is going to kick out a false. Likewise, the same thing occurs in the second one, which is why that one's going to be false as well. So in this case, the A if and only if B is going to somehow give us some information on not necessarily if A and B happen to be true or false, but it's going to tell us if they're the same. So it's just basically a read if they're both true or if they're both false in this case. And you can see that this column over here and this column over here do in fact happen to be the same, which is why we're going to say that these two statements are actually logically equivalent. And more about that as we go farther into this chapter, but kind of foreshadowing what's to come, a little bit of this idea of we can always create two different statements. If they happen to have the same truth value, they are going to be logically equivalent. So that's what's going on in the biconditional. It's kind of cumbersome to work with. I like to view it as two separate conditional statements. It's a little bit easier to work with, kind of lets me wrap my head around what's going on. But if you like the idea of A if and only if B, just basically indicating if those things have the same truth value, either both true or both false.